Hey, welcome back to our programming channel. Today you will become a Python strategist because we are going to illustrate a design pattern called the strategy pattern. The strategy pattern is a behavioral pattern that allows you to define a family of algorithms or a family of functions and encapsulate them as objects to make them interchangeable. Let's imagine you are building a food delivery application and you want to support many restaurants. But each restaurant has its own API, and we have to call each restaurant API to perform diverse actions such as ordering a food, getting the menu, or checking the status of an order. So we have to write custom code for each restaurant. So first, let's try to see how we can implement this using a simple and naive approach without that much bothering to think about the design or the architecture of our code.
And here is our Python code. For simplicity reasons, I've just printed what the code is supposed to do instead of the write code or the real code. So we have an enum here, which represents a restaurant. To define a different restaurant that we support, we have the Geranium, we have the Atomics, and we have the Clarence. We have an enum food, which lists the food that we support. And we have a simple map here to know the food that are currently available in each restaurant. And we have the function getRestaurantFoodMenu, which takes as argument the restaurant and return the list of food available on that restaurant. Of course, it checks the restaurant type, and according to the restaurant type, it makes a call to the right restaurant API to get the menu. We have the order food function, which takes as argument the restaurant and the food to order and returns an integer representing the order ID. Again, it checks the restaurant type, and according to it, it sends the notification of the order to the right restaurant and returns the order ID. And finally, we have the check food order status function, which receive as argument the restaurant and the order ID and returns whether or not the food is ready for delivery. And we have our main function here, and inside it we have retrieved the menu of the Atomics restaurant. We have printed it, we have ordered the first food in that menu, and we have printed if the food is ready or not. And if we run, it's working. But what is the problem with that implementation? There are two problems here. First, the logic related to each restaurant is scattered. So to add or modify the code related to a restaurant, we need to update all or many of those functions. So to add a new restaurant, we have to add an else if condition in the check food order status, an else if condition here to check the type inside the order food function, and an else if condition here right after this one to get the food menu. And if we have more other features in the future, the code will be more scattered. So that is the first issue. The second issue is that each of these functions contains too much code. Remember, I have simplified the code to just print what the code is supposed to do. But for each restaurant, if we have to write the real code, it might be a bit long. We have to make API calls, we have to handle errors and potentially other behaviors. So imagine that for 10 restaurants and more inside each function. So it's too much code. And here is where the strategy pattern enters the game. Each time someone orders food from a given restaurant, we can consider that he is performing the action of ordering a food using a given strategy. And the strategy here is the restaurant. So each strategy and all the functions related to it, which constitute its family, will be encapsulated into a class. So let's do that. First, we need to create a restaurant strategy class interface or abstract class. So for that, we need the ABC module of Python. ABC, and also the abstracts methods module. So let's name that abstract class restaurant manager. It inherits from ABC abstract class, and we add an attribute named restaurant of type restaurant, which will set it at none by default, but it should represent the restaurant, the current restaurant type. So we add an abstract method. For each feature, we add an abstract method. So for the get restaurant food menu, we have an abstract method. It's abstract because each of the subclass which represent a restaurant should implement it. And as it will be called from a restaurant object, we don't need to add restaurant. Get food menu is enough. Get the list of food available. So we do the same for the other food. And okay, I have forgotten here to add pass. And finally, we have to do the same thing for the check food order status. And we add pass. So another thing to change, but we have to change something. Now in the abstract class, the restaurant, we don't need to pass the restaurant anymore because the restaurant represents the class itself. So we should replace the restaurant by self. Here as well. And here too. Great. Now, each restaurant code will be grouped inside its own class, which just inherits from the base restaurant manager, and should implement all the required methods, all the abstract methods. Let's do that for the Atomis restaurant. It inherits from the restaurant manager, and the attribute restaurant in that case will be restaurant atomics. Of course, it needs to implement each of those methods. For the get food menu, we can just copy and paste this. We should not forget to return the value. Now we have also the order food. Or before that, it will be self restaurant now. Yeah, that's great. We replaced. we replace this by this. And finally, we have check food status. And we copy and paste this. And it will be Atomix. So great. Now we can add a simple business class that will just receive the right strategy or the right restaurant. Let's name it food order processor. In the constructor, we receive the restaurant manager, which is an instance of restaurant manager. So here we can reuse the abstract class. We don't need to pass a concrete implementation here. And that also calls the dependency inversion of the solid principles, which states that high-level module or high-level class should depend on abstractions rather than a concrete implementation like Atomix Restaurant Manager, which is an implementation of this abstract class. So if you don't know about the dependency inversion or the solid principles, I previously made a video about it. You can check it. So here we have to set the manager. Okay, great. And we add the utility or the feature method that we just call the right manager method. So self restaurant manager get food menu. Order food, the same thing. We have to return it here. The food menu, we have to return it here too. And finally, we have to return manager of the order ID. And we have to modify our main function. So we can create an instance of our business logic class, order processor, and we create a processor by passing or using the Atomix Restaurant Manager. So we call the method of the processor, get food menu. We don't need to pass this anymore. We can print the menu. Then we can call this method from the processor and also here from the processor. We don't need to pass this anymore. Check food order status. So if we test, it should still work. And it's working. So if we want to add a new restaurant or a new strategy, we just have to create a new subclass of this abstraction. So let's add the restaurant geranium. So geranium restaurant manager, which inherits from the abstraction. We can copy and paste this. Here it is geranium Geranium, Geranium. So the code, all the code related to the Geranium restaurant is inside this class now. And to change the strategy of the restaurant, we just have to change it here. And if we test, it's working. And that is, we have successfully implemented the strategy pattern in Python to create interchangeable restaurant gateways for our delivery product.
And that's a wrap for today's video. I hope you found this explanation of the strategy pattern helpful. And remember, the strategy pattern is just one of many design patterns that can help make your code more maintainable. If you enjoyed the video, don't forget to like it and share it, and hit the subscribe button to stay tuned for more programming content on our channel. I see you in the next video. Take care.